Yeah.
Test.
All right. How's everyone doing this morning? Pretty well? Cool. Okay. All right. So I'm going to talk about the MITRE attack framework, which is kind of new concept. If you haven't taken a look at it yet, I think this talk will probably get you to take a look at it. So just a little bit about me. I teach at RIT. So I run the undergraduate program. I'm the undergraduate program director there. I occasionally do some other stuff, ATT&CK Background. I write team on the Windows sub-team for another student competition, which there's a big story, I guess a case study, I'm going to call it a case study on this, about my experiences using MITRE attack framework to actually do some red teaming at the student competition. I'm also technical director for the Safe Lab at RIT, where we do what, since it's academia, we call applied research. Anybody else would call consulting. Contact information is up there. One thing I want to note here is that a decent amount of this talk also comes out of student projects. Unfortunately, for various reasons, I can't actually give out the names of those students. So I want to give them a shout out, and I will mention specific students wherever possible as part of this. Okay, so we're going to start off with a little bit of background about the attack framework. If you haven't looked at it before, we're going to cover a sort of a case study of me taking a look at using the attack framework for a red teaming exercise, which I've got a nice
background. Don't worry, it's all fine. And we'll take a look at using attack framework for automated attribution on a network. So the background for the attack framework, basically their goal, and they've got a really interesting philosophy paper that describes their motivation and what they hope to accomplish with the attack framework, is to systematically categorize adversarial behavior, which I think is interesting. They've got a lot of specific use cases for this, but the sense that I get is really what they're interested in doing is threat intelligence and improving detection capabilities. And that's what a lot of the research so far has been oriented towards, is using the attack framework and using the various the data that MITRE's making available through the attack framework to do better threat intelligence and better threat data collection, better threat analytics. There is some adversarial emulation going on right now, but most of it's automated. So if you've seen Caldera, I'll talk about this again in just a minute. But there's a lot of automated adversary emulation, but it's not adversary emulation that's useful in engagements or assessments. It's more useful for calibration of tools to see if your SIEM is doing what you want it to, that sort of thing. And then there's a lot of other goals that they have that they're really not getting into. So the way that they approach this is by taking these techniques and grouping them into categories. So a technique is a specific adversarial behavior, and they group them into broad categories called tactics, and then associate the technical data with techniques. So tactics, these are broad goals. MITRE has 11 of these broad goals. Initial access, execution, persistence, PREVESC, etc. Kind of things that you normally do in an assessment. And then they have a bunch of techniques. So there are 174 techniques that are associated with things that happen before attack, pre-attack. There's at the current time, there are 244 enterprise techniques, and I'm going to be specifically talking about the enterprise subcategory of the MITRE attack framework. At the time we did our research, there were 224, which was interesting because MITRE released an enormous update literally the day that one of my grad students was defending his capstone project. So, yeah. Needless to say, he did not want us to ask him to do more work. And then they have 6 to 7 mobile techniques. There is if you looked at before, I don't know, 5 months ago, 6 months ago, like I said, they did release a huge update at the end of April or at the beginning of May. So here's what one of these techniques looks like. So this is the pass the hash technique, which many of us are familiar with. Every technique gets an ID. You see the tactic that it's associated with, and then as you look at the technique, a lot of times it offers specific guidance where available. So in this particular example, you can see that there's a registry key associated with it, along with some recommendations for how to mitigate the pass the hash. I will say this is probably one of the more useful ones. Some of them, there's a high degree of variance when it comes to what advice MITRE provides that's actually useful in the field. Sometimes it's useful, sometimes it's very highly useful, sometimes it's not so useful. Sometimes the nature of the technique means that you just can't have useful things, such as phishing. There's some phishing techniques that are listed in the attack framework that really, there's not a lot of good technical guidance for them because it's too broad of a category. What I don't have shown here, and I've got in a later slide, they also identify the specific adversaries that are using these techniques in the field wherever possible. So I think that's some interesting insight that we don't currently have, and that a lot of detection tools don't currently have, is the ability to at least potentially do some kind of attribution, although we've got to be careful about how we approach that. So we had a one initial research question is how much of the attack framework could actually be used for penetration testing? Okay, so how much of the attack framework actually makes sense? Because when you're out doing pen testing, there are things you just don't do some of the time, right? You've got scope issues, you've got things that are dangerous to carry out, things that can impact availability, etc. So at the time of analysis, we looked at 224 of the enterprise techniques and found that 179 of them, or 79%, were clear yeses. There's no reason you couldn't use these techniques while on a standard network penetration test, which I think is kind of an interesting finding because it provides some justification that if you're looking at attack and using an attack at the attack framework as a starting point for some of your methodology, that since the attack framework is based on real adversarial behavior, your penetration tests could really reflect what adversaries are actually doing out in the field. And one of the common criticisms of penetration testing is that it's not that realistic for various reasons. So maybe by using the attack framework as a starting point for our penetration tests, we might be able to make them a little bit more realistic. The other 21% or so couldn't be used for various reasons. There was only one that was like a clear no, and I don't remember what it was off the top of my head. There was one technique that we identified that was a clear hard no, and then the other 6 categories of techniques that we saw, we determined they were maybes depending on the scope and the discussion with the client. So, for example, is social engineering in scope? Some pen tests yes, some pen tests no. Do we want to interfere with detection capabilities? Do we want to modify the client's ability to detect our behavior? Some of the time, yes. Some of the time, no. Right? It depends on your discussions with the clients. Credit for this, this particular research goes to my grad student, Joe Graham, fantastic student. So, existing tools for attack. I found it interesting. One of the defense tools is actually exactly the same one that Dave mentioned in his talk, half an hour ago. Sysmon Modular. It's a great tool for using Sysmon to tag Windows events with particular MITRE attack framework technique IDs, so that if you forward it, for example, to an ELK stack, you can get some visibility into what techniques are being used in your environment. Swift on Security released one of these recently. I haven't had a chance to look at and compare these yet. I do have some complaints with Sysmon Modular, but it's a work in progress. On the offense side, you've got MITRE's Caldera tool, you've got Atomic Red Team, and then Red Team Automation. And these tools, they're interesting, useful tools, but they're largely meant to calibrate detection capabilities. Okay, these are not tools that you can actually use out on a pen test. They're not meant to be that. They're meant to be largely academic or to be run on boxes that where you already have detection capabilities. You can't like pop a shell with Atomic Red Team or pop a shell with Caldera. Instead, it runs some script that is supposed to emulate a particular technique, which is something that I think is worth looking into. Having something that's Metasploit-like or PowerShell Umpire-like that explicitly associates techniques, features within the framework with MITRE framework techniques would be a valuable tool. What doesn't exist? Well, I already said that penetration testing platforms that are aligned with the MITRE ATT&CK framework. There aren't a lot of vulnerability assessment frameworks that are aligned with ATT&CK yet. I think an interesting project that I'm going to probably try and recruit some students to work on is looking at standards that align with ATT&CK. So, for example, I think it would be interesting to look at PCI and see how the PCI recommendations match up with the mitigations described in ATT&CK. And then configuration verification tools. So there are some emulation tools that do configuration verification, but it's not the best. All right, so we're going to start into story time, or as I said, case study time. And this particular case study is about me red teaming for a student competition. If you're not familiar with the student competition space, there are a huge number of student competitions out there. The one that most people are familiar with is CCDC, this Collegiate Cyber Defense Competition, in which case students must defend their infrastructure against a team of professional red teamers. And I'm using red teamer here specifically, not penetration tester. There's the Collegiate Penetration Testing Competition, where the students act as penetration testers and attempt to conduct a penetration test on the simulated client, where the students are graded not only on their technical findings, but on reporting, presenting, and they have to actually present to a board of real executives that get brought in. And they also get graded on client interactions. This particular story is about one of the competitions that our students put on, the Information Security Talent Search Competition, where students must defend their infrastructure against professional red teamers and against each other as well, which makes interesting. There's few rules on this about pre-staging things, which sometimes goes well, sometimes doesn't go so well. One of the teams this year, for example, had a script that they dropped at minute 0 that replaced all the System 32 binaries on every team's Windows, all of their Windows boxes, with a binary that just printed out the word no. Yeah, that was not fun. And we host IRSEC. UB, University of Buffalo, has UB Lockdown. And those are both student-on-student competitions. This is definitely an incomplete list. I'm not including any capture the flags or anything of that nature in here as well. So this is a case study about using ATT&CK framework for red teaming ISTS, which has a very informal, red team-oriented approach where we end up having a lot of fun with the students too. It's really framed as a learning exercise as well. The students get to actually interact with us as adversaries and ask us questions, and we usually extract some kind of toll. So this year we had the scenario was the Pakistani national elections, and the red team was the country of IHAC. And we gave one team, for example, we gave them their domain controller back after they wrote us an IHACI national anthem and performed it. Okay, so the backstory to this is that I red teamed at ISTS 16 in February of 2018. Mobile phones were added at the very last minute. I got brought in at the last minute to red team because none of the other red teamers had mobile experience. I wrote the absolute worst C2 that I've ever written in my life for that in less than 24 hours. It was scripted key presses controlling Android using ADB over TCP/IP. So I had to spec out screen size and figure out where the pixels were that I needed to press. It was awful. It worked, but it was awful. However, I learned a lot of the stuff that my fellow red teamers were doing, which made it into some of my classes, particularly the Authentication Security Models class that we teach. So I joined the red team again this year. I wanted to learn. I wanted to not write awful code. And ATT&CK was kind of gaining popularity, so I said, you know what? I'm going to do something that's ATT&CK-oriented, and that's the story of this. So I did a needs requirement. Red Team was really strong on Linux and web, but we were weak on Windows. Our main approach was going to be using Cobalt Strike pushed out at minute 0 for an implant. We were a little bit concerned that this would have a very high likelihood of detection for various reasons, for a lot of the reasons that Dave identified earlier. It's a popular tool, AV pops it a lot, etc. And those were absolutely valid concerns. Also, incidentally, Cobalt Strike does not run if System32 binaries are replaced with something that just prints no. It took us an hour to debug that. So we needed some custom implants that had a low likelihood of detection that kind of would run under the radar, primarily for persistence, but secondarily for shenanigans. So I just kind of approached the ATT&CK framework and pretty much used the throw the dart at the board to see what made sense. So I looked at the persistence category and said, all right, I'm just going to pick some random techniques and see if there are things that I can do within my time frame. So first was the one I first picked was Office Application Startup, technique T1137, which is template macros, DLLs that automatically get loaded off of a particular registry key. I'm not particularly familiar with VBA for Office macros, also not really a reliable technique for the use case, because our students weren't using Office in this environment. So rejected for various reasons. Second technique was T1158, hidden files and directories. I don't really understand the classification for this and why this is considered a persistence tactic when it doesn't actually result in code execution. It seems to be a miscategorization. It really should be categorized as an evasion technique, but I don't know. That's just me. Third try, run registry keys. Okay, so interesting exercise. There's some a bunch of registry keys on boot. I've got an example listed here. So it seemed like cool idea. I have never, actually before this exercise, had never written a custom DLL before. So good opportunity for me to learn. But I was concerned, and rightly so, that it would be pretty easy to catch. And also that it would have limited utilities because the students don't get a lot of machine reboots during this competition. Instead, they usually revert their machines, if you will. In other words, they can use points to purchase restorations from snapshots. So I was a little bit concerned that it wouldn't run that frequently, and that it also, when it did run, it would be pretty easy to identify, since it is a very, very commonly used technique, and I'll show you just how commonly it is used in a minute. So rejected that for various reasons. App init DLLs. Okay, cool. Technique T1103. It's a DLL that fires anytime anything loads user32.dll. Cool. A lot of things load user32.dll. All you have to do is put the DLL in this registry key, and it gets fired. So it seemed like a good idea. Tried it out, wrote my malware, tried it out to see what happens, and it did not work very reliably. There were some pretty significant differences between 64 and 32-bit systems. It was technically interesting, but it didn't really work in practice. So I wouldn't recommend it. Some of the source material that I found as well was not really. They had exactly the same experiences that I had. So authentication. So I moved on. Authentication package. It's sort of like a PAM module on Linux, which I found fascinating. And we use PAM modules to a high degree of success in ISTS. Yeah, and I shouldn't say almost nobody finds our PAM. Somebody did find our PAM module this year, and that got popped. So we'll have to redo some stuff for next year. But in looking into it, it didn't seem like something that I could feasibly do during my development time frame. Okay, throw that one away. 6-star thrown. Absurd DLLs fires any time the create process or one exec is called. Oh, okay, that's nice. Including any time that Windows invokes any one of these, which it does on boot. So pretty much guaranteed administrative code execution on boot. Okay. Yeah, so this is what I ultimately decided to go with, and it worked pretty well for the most part. Now, to see which adversaries, if you will, and this is one I think what makes attack a little bit more interesting, is that you can get some insight into, when you use techniques, what specific adversaries you're actually kind of working with. Remember how I mentioned that registry run DLLs used by an enormous number of people and would be too easy to catch. When I actually went and prepared this slide, there were too many for me to fit on any reasonable slide. I would have an entire slide filled up with the threats that were using this specific technique. And it's not surprising that when I actually rolled it out during the competition, it was caught very, very quickly. But yeah, so some of these were very commonly used, some of them not so much. And am I good? Okay. So the specific technique that I used, there was some operational guidance in the attack framework. There was the registry that I have to set. However, there was a lot of actually information, really relevant information to developing something for this that was missing. So it showed me the registry entry that I would have to set. It showed me when this gets invoked. It very interestingly told me that tools such as sysinternals are very likely to overlook this as something that gets started automatically. Those were all things that influenced me in picking this option. So it was good. It was a good choice. But as I said, there were some crucial details missing. If you haven't written a DLL, I'm just going to move through this quickly. It's reasonably straightforward. You've got, in some other code, you invoke load library and you point load library to DLL. You pick a particular function from the DLL to import, and you do your thing. In the DLL up top, you have some function that you export, and when you export it, it can be imported to a different binary using git proc address. Okay. Now, what's interesting is load library. The reason I'm mentioning this is load library, and I learned a lot about the way that load library actually works as a part of doing this. So I'll come back to that in a second, though. So the broad strategy for this was to build some malicious DLL, be sure to export DLL main, because that's the thing that gets invoked when absurd DLL loads. Move my malicious DLL onto the system, point the registry entry at it. You can see my very, totally legitimate name, blah, 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 blah. And, profit. So what I was able to do with this, and I'll talk about this in a second, add a local admin, disable firewalls, enable RDP, 1RM, change background, persist, and persist, all persist does is replicate this into other locations, as well as use a couple of different techniques for other forms of persistence. Now, what I learned, very interestingly, is that this cannot create processes. And the reason that it can't create processes is that load library acquires something called the loader lock. Loader lock is, so the loader lock gets set before DLL main gets invoked, and when load library completes, it gets released. Okay, so if you're following this, we're calling load lock gets called when the absurd DLL gets loaded as a part of executing. Now, create process also invokes load lock, which is a problem. So if I actually try to create a process from this particular DLL, the loader lock has already been acquired by Windows to load the library. Create process is going to be waiting on Windows to release it, but Windows isn't going to release it until the DLL gets finished, and the DLL can't finish as load lock is already acquired, which is deadlock. This is the first time I've ever actually encountered deadlock in the field, and I bricked a bunch of VMs before I figured out what was going on. Because if you set this, it fires at boot, and Windows does not play nice if you deadlock on boot. Okay, so payloads. What can I do if I can't actually create a process? Turns out there's quite a lot of stuff, and Microsoft has some fantastic tutorials to do nefarious things. Pretty much all of these are straight following of Microsoft tutorials. So, adding a user, there's a library for that. API calls. So you invoke net API 32.lib. You specify the groups that you want this user to be in. So you can see that I'm adding a user called Colonel Sanders, who was Colonel Sanders was our fictional candidate in the election. So we got Colonel Sanders elected even though he wasn't actually running. So Colonel Sanders, and we added him to administrators on the local machine and remote desktop users. It's pretty straightforward. You just create a user info object, set all the various settings, provide a password, which does have to match the password policy. You specify the groups that you want to add, and then invoke it actually add the user with net local group add members. Very, very straightforward thing to do. Okay, so we added a user. How about remote desktop? I was shocked at just how much remote desktop wants to be on. Okay, so remote desktop sits there and monitors this registry setting F-deny TS connections, and as soon as that gets set to 0, it immediately turns on. I couldn't believe it. It was crazy. There was absolutely nothing else I had to do to get remote desktop on. Similarly, changing the desktop background, this was pretty straightforward. There was a system parameters API that I could use to do that. All I had to do was specify the path to the new image. Enabling WinRM, though, that was a tricky one. Compared to starting up the remote desktop service, enabling WinRM was a pain. And to be honest, I'm not ever sure that it actually fully worked. We never used it in the field on the day of, so I don't know. There's IP values that needs to be set. There's a bunch of registry controls. I've got one slide that I'm going to fast forward, and you can see my comments, things like take care of the service, I hope. Take care of setting group policy, I hope. It was messy. And like I said, I'm not entirely sure that this ever worked, but if someone wants to try this, off the video, more power to you. We didn't end up actually need it. How about disabling the firewall? There's a Microsoft tutorial for how to disable the firewall via DLL. Cool. All you do is you fetch a firewall object, you tell it to disable, and then you apply the firewall policy. Pretty straightforward. And then here's a quick video of this actually in action. Hopefully my video goes a little bit better than Dave's. So you can see that we've only got 2 users here, administrator and guest. Just kind of demoing the before. Firewalls are on. Remote desktop here is off. Okay. And then all we're going to do in a second is set a registry entry. And if you can see it up here, there was a little thing in the upper corner, leech.dll, and we're going to invoke leech.dll in a second just by turning on Internet Explorer. So I set a registry entry and say, my registry key is why is this a thing? We'll point it at DLL sitting on the desktop. Okay, just a quick check because I type out this like 3 times. And then open Internet Explorer, and yeah, totally fine. So net user, you can see we've got a new user, Hacksaw. Funny thing, net user itself is a binary, so this gets fired when you use net. So even if I delete the user like I just did, the act of deleting the user caused this DLL to get fired, so good luck. So remote desktop is on, and then firewall is off. We deployed with Ansible. Pretty straightforward. We use a win copy to move things over. There's a WinRegEdit tool in Ansible for that as well. Actually, on the day of, we used the registry key name, This Is Bad. Surprisingly, not many people found that, even though that was a pretty big giveaway. One thing, though, about if you're trying to deploy stuff with Ansible, we were pushing out to, I think we had 5 Windows boxes for 13 teams, so that's, 65 hosts. That took a surprising amount of time. So one of my takeaways is that Ansible is not great for staging for these kind of competitions, at least for doing minute zero staging. Technique success. So I ended up actually using 3 different techniques. They're all roughly the same thing. Run registry keys works in exactly the same way. You just point at a DLL, the DLL gets fired. NetSH helper DLL, same thing. You point a particular registry entry at a DLL, the DLL gets fired whenever NetSH is invoked, and then after DLLs. So we had 3 different implants: Colonel Sanders, Sauron, and King Joffrey. All good people that you want running the country of, the sovereign country of Pakistan. Most of the student teams found the King Joffrey implant. Several student teams found the Colonel Sanders DLL using when they actually investigated the Windows events, but none of them found the registry entry, at least as far as I'm aware. No teams found the Sauron implant at all. Okay. The way that most of the teams defeated me was by disabling the Colonel Sanders user account. Okay, so obviously one of the things that I'm going to do in the next iteration of this is make sure that the account gets enabled if it already exists. And Windows Firewall stayed disabled for pretty much the entire configuration, right, Langston? Yeah? Windows Firewall was off pretty much the whole time for everyone, right? Yeah. Cool. Okay, switching to defense. So that's the end of the case story using this for using the attack framework for red teaming. And overall, I feel like it was a pretty good success. I'm going to continue to use this strategy in the future. Now, switching to defense, we had a research question. This was actually submitted to us by MITRE as a undergraduate student capstone project. Can we use attack to automate attribution and improve detection without purely relying on signatures? So we had some assumptions that we as researchers made as a part of this. We assumed that there is an adversary in the system. We assumed that some adversarial behavior has been detected. So this is very explicitly not a detection tool. Okay. We assumed that there were users in the environment besides the adversary, and that one of the things that's going to happen is that false user behavior will generate false positives. And we also assume that we have tagged events within some time window. So we developed an analytical model. There were a couple of iterations of this, but the one that we finally settled on is that we were going to weight techniques that we saw based on the number of adversaries known to use the technique. So techniques that are very commonly used are weighted less when attributing the behavior to a particular adversary. Techniques that are used more rarely are contribute more to that attribution. We were going to examine the techniques used within some given time frame to score the likelihood of each adversary being present, and then adversaries earn the weight of each particular technique if they're known to use that techniques. So we developed so this is essentially a probabilistic model, and it shows you the probabilities for every adversary, all the adversaries that the attack framework knows about, and their likelihood that they're present based on the techniques observed to be in use during that particular time window. And the adversary with the highest score is the one most likely to be present. So I think that's a pretty straightforward analytical model. And what this looks like on paper is, so let's suppose that we have 5 adversaries, 1, 2, 3, 4, 5, and 5 techniques. Okay? So let's suppose technique 1 is very commonly used. Almost everybody uses, in this case, everyone uses it. Technique 2, 2 people use it. Technique 3, 2 people use it, etc. Okay? Now, let's suppose that we've got some window, we've determined that there's an adversary present, we want to know which adversary is in the environment. So let's suppose that during that time window, techniques 1, 2, and 3 were used. Okay? So techniques 1, 2, and 3 are used in some combination by adversaries, used in some combination by all the adversaries. Okay? So when we look at APT1 in this scenario is known to use techniques 1 and 2. So even though technique 3 was observed, they don't get any credit for technique 3 because they didn't use it. And when we look at the weight that each technique observed uses, the 1/5, which in this example, since everyone is using it, could really this value could really be normalized, and we could drop that 1/5. We just take we distribute 1 over the number of APTs that actually use, in this case, all 5. So APT1 earns 1/5 or 0.2 from technique 1. They earn 1/2 from technique 2, or 0.5, for a total of 0.7. APT2 earns 0.2 from technique 1. They earn 0.5 from technique 2, and they also earn 0.5 for technique 3, giving them a total of 1.2. APT3 only is known to use technique 1 of the techniques that were observed, so they only have the 0.2. APT4 is known to use technique 1 and technique 3, which in this case is functionally indistinguishable from APT1. They end up with a 0.7, and APT5 is similarly indistinguishable from APT3, since they only are known to use technique 1 of the techniques that were observed. Okay? So in this case, the adversary most likely to be present is APT2. They have the highest score. So let's look at one other scenario, same kind of thing. Okay. Oh, I forgot to color code the winner. So same scenario, but we have different techniques used. So techniques 2, 3, 4, and 5 were known to be used. All right. Now notice that there is no single adversary who is known to use all these techniques. Okay, and this is what makes it a probabilistic model, and not just a straight signature-based one. And also gives us the ability to potentially identify APTs or adversaries using techniques that they weren't previously known to use before. Okay, so in this case, the math is kind of similar. However, the main difference is that APT2 in this scenario also comes out the winner, even though a technique was observed that they're not known to have used. Okay, so if I were investigating this, I think that it would be a reasonable scenario. It would be reasonable for me to look at, hey, is AP2 expanding the pool of techniques that they're using? Okay, so it gives us the ability to evolve this a little bit. So how does this actually work in practice? We generated an environment that we were using to emulate this. This was the subject of a couple of undergraduate capstone projects. Unfortunately, I can't attribute this to any particular students right now. So we had a couple of machines that we were monitoring. We used sysmon modular on the machines that we were monitoring to tag techniques. The GitHub for that is earlier in the presentation. We used Atomic Red Team to emulate particular adversaries. So we ran Atomic Red Team on the host that we were observing to emulate particular adversaries. The traffic got forwarded to our ELK stack, and then we had some API in the background, some analytics that we used to actually do all the computations and come up with a result. Okay, so how did we actually do? And the answer is badly. Okay? This is a lesson in note the fact that failure is always an option. All right, and that failure should not be something that you necessarily. It should be something that you learn from, but that you don't necessarily get discouraged by. Right? When you fail, you want to sit down and try and figure out why you actually failed. And in this case, in a minute, I'll talk about some of the very good reasons why this did not work. Okay. But just to talk about this for a second, we were correct 9% of the time. So we knew which adversary we were emulating, right? We identified the specific techniques that we wanted to emulate, and our analytics correctly classified those techniques as being associated with a particular adversary 9% of the time. Okay. So we won 9% of the time. I would say we did pretty well 17% of the time with having the APT that we're emulating in the top 5 results. Okay, I think that's a pretty good. That's still a pretty good result when you try and think about which adversary is in the environment. But when you put those two together, we're still only doing okay, at least pretty okay, 24% of the time. Right, that's still not great. We had the adversaries detected, but not ranked highly 63% of the time, and 11% of the time the adversaries that we were emulating were not detected at all. They weren't even in the list of possible adversaries that were in the environment. So total failure, total obliviousness, 11% of the time. Okay? But we then dug into why this was, and we found out that there were actually quite a few different confounding variables. First is that there are many adversaries that have a high degree of overlap. So when you look at the set of techniques they use, there's a bunch of different adversaries that the attack framework details that overlap in their behavior, which is really not that. It should really be expected, and it's not something that occurred to us ahead of time, but it should have. However, that really wasn't the big thing. The big thing was in the capability of the tool sets, the tooling out there to carry out this kind of analysis. So, of the tools that we found to actually do the adversary emulation, Caldera at the time that we did the analytics, Caldera could only emulate 14% of the techniques in the attack framework matrix. That's not very many at all. Okay. Red Team Automation could emulate 21% of the techniques. Atomic Red Team was the best at 57% of the techniques. Okay, which is again why we picked it. Sysmon Modular, which at the time was the only MITRE attack framework technique log tagging tool that we found, could only successfully tag 55% of techniques in Windows logs. Okay, which is not really that high of a number when you think about what these are. And the overlap, so we eventually identified Atomic Red Team as what we wanted to use, and Sysmon Modular is what we wanted to use, and then we analyzed the overlap now. After the fact, we actually analyzed the overlap and found that they only overlapped in 44% of the techniques. Okay? So we ran our experiments knowing that we could only probably, in the best case scenario, identify successfully 44% of the techniques, which is less than half. And then we failed hard, so we actually dug into the internals of Atomic Red Team and dug into the internals of Sysmon Modular and found that, hey, these things are emulating and tagging techniques differently. Both are reasonable, but both are different. They're not aligned with one another. So the way, for example, that Atomic Red Team emulates a particular technique is not at all, it's not going to generate the same set of Windows events that Sysmon Modular is going to tag when it sees them going through in the Windows log, in the Windows event log. And that's kind of where we left it at the moment. We figured this out week 14 of the semester. So obviously not enough time to have the students go back and rework this. But I think it's a very interesting finding that these tools were really not aligned and that it had a pretty high impact. We've got one of the things I think let me take a step forward. So future work. On the defense side, we really want to do a detailed gap analysis between technique emulation and technique tagging to see why there's the gap between these. Okay, to see if we can figure out why atomic red team is emulating techniques in particular ways, and why Sysmon Modular is monitoring and tagging them in particular ways. We're also kind of interested in doing a comparative analysis of tagging projects. So very recently, as I mentioned earlier, Swift on Security released something that is I would say, a competitor to the Sysmon Modular project. And we've got to look at how that particular Sysmon config does and how it matches up against Sysmon Modular. On the offense side, I think this generally worked very, very well for offense, and I would strongly recommend that one look at, if one is struggling with pen testing or wants to learn how to be more effective at pen testing, that you look at the attack framework and work through some of those techniques. The techniques actually worked really, really well for red teaming. Deployment needed some work. Like I said, Ansible, I think we're going to probably come up with some custom stuff over WinRM. I hope students are watching this are plugging in ears for that. And then working on some integrated technique C2. So where we have a bunch of command and control that we can actually use in the field that's on pen tests and on engagements that's aligned with the attack framework. So one success, one temporary I won't call it maybe failure, I'll call it a setback, but with a lot of hope for the future. And questions? I feel like I'm pretty good on time. Perfect timing. So questions? Yes, no?